Greetings everyone, we are from Group 1, Section 2. We present our PBL, which is Digital Attendance Counter System. So this is our group member, which is consists of 5 members. First is Ahmad Khairul Shafiq, Alam Mahulda, Amiran Hazim, Ammar, and also me, myself, Angelina.
Next, I will present for the introduction. This project introduced a digital attendance counter system designed to improve attendance management in classroom. The system used digital logic component to count student attendance automatic, display current count, and stop counting once the preset attendance target has been achieved. That's all from me.
So this is our filler table, which is consists of 6 points, and here is the first 3 points of our filler table is insert in the report. And here is the last 3 points of our filler table. So this is our review article, which is Smart HD Attendance Management System by Razak, published at 2021, which is the objective are to develop an automated attendance system to improve attendance recording accuracy and also to reduce human errors and also attendance fraud. And the technology used is NFC, QR code, and also Bluetooth beacon. So, the similarities of this journal relate to our digital attendance counter system is first, it is automated attendance monitoring, second is real-time attendance tracking, and third is use digital technology to improve the efficiency. And our system components, we are using 74LS147 encoder, 74LS90 counter, 74LS85 comparator, and also 7-segment display. So the conclusion of our journal summary is both system aim to automate attendance monitoring. It also, the journal provides useful ideas for developing our attendance counter system. So that's all from me. Let's move on to the next part.
Now I'll explain the problem statement for our project. The main problem is that the traditional attendance methods such as rolling, call, and paper signing sheets are not efficient, especially in large classes. So this is the problem statement. Now I will continue with the objectives. For the objectives, our project aimed to design a digital attendance counter system using all the SSI digital logic components without using microcontrollers or analog devices. We also aim to analyze the logic circuits, simulate the system using Protos, and evaluate its performance through the counter 7-segment display, LED indicator, and automatic shutdown. Lastly, this project helped us understand digital system design through problem-based learning. This is all about the objectives.
Next, our methodology. I will start with the block diagram. First, we select the target attendance using switches, switch 1 to switch 9, a 74LS147 encoder, and 74LS04 inverter. Process this into a stable preset value for the 74LS85 comparator. Pressing the set button triggers the SR latch, turning on our status LED and sending an enable signal to the 74LS08 AND gate. This acts as an open door, allowing pulses from the count button to pass into the 74LS192 counter, which is then decoded by 74LS47 and shown on the 7-segment display. Moving to the flowchart, we can see the step-by-step system execution. After the SR latch is set, the system waits for a count button press. If the AND gate is enabled, the pulse passes through the counter increments and updates the display. The system then compares the current count to the preset value. If A equals to B is no, it loops back to wait for the next input. If yes, it instantly resets the SR latch. The enable signal drops to low, the LED turns off, the AND gate is disabled, and the counter stops permanently. Now, I will demonstrate how our attendance system works. So as you can see here, I close switch number 7, then I press the set button followed by the count button. And the number starts going up until it reaches 7. The LED then turns off after it reaches the target value, which in this case is 7.
So during the analysis stage, power is applied to the circuit and user selects the desired attendance target using the switches. The 7LS147 encoder processes the selected value and sends it to the comparator. At this stage, the button has not been pressed yet, so the SR latch remains set, enable signal is low, LEDs is off, and the AND gate is disabled. As a result, the counter cannot receive any clock pulses and the system waits for the activation. So active counting state is the state where the set button is pressed. When this happens, the SR latch enters the set state, the enable signals become high, the LED turns on, and it enables the AND gate. Each time the count button is pressed, a pulse passes through the AND gate and increments the 7LS192 counter. The current count is displayed on the 7-segment display through the 7LS47 decoder. At the same time, the 7LS85 comparator continuously compare the current count with the preset attendance value. This system continues counting until the target value is reached. So active counting state is the state where the set button is pressed. When this happens, the SR latch enters the set. So we are moving to the halt and lockout state. When the current count becomes equal to the preset value, the 7LS85 comparator detects the A equals to B condition. This signal reset the SR latch, enable signals become low, the LED turn off, and the AND gate is disabled. Any further count button pressed will be ignored. The final attendance value remains displayed on the 7-segment display until the system is reset. The simulation shows that the digital attendance counter system operated as intended. The counter recorded attendance input and displayed on the 7-segment display. When the attendance reached the preset target, the comparator reset the SR latch, stopped the counting process, and turned off the LED. This demonstrates the effective use of counters and comparators in a hardware-based attendance monitoring system.
Okay, lastly, I will present for the conclusion. In conclusion, the digital attendance counter system was successfully designed and simulated using SSI digital logic component. The system accurately count attendance, display the count in real time, and automatically stop when the preset was reached. Overall, the project improved attendance management efficiency and enhanced understanding of the digital electronic system design. That's all from us. Thank you.